Wilson family is driving in from out west. Everyone is coming to the New York World's Fair. They're coming from the four corners of the earth and from Five Corners, Idaho. They come down from New Athens, Maine, and from Athens, Greece, and from Tokyo, and Kokomo, and Rome, down from Frisco and down from Troy, from Hamburg, from Nineveh, from Aurora, Illinois. Troop 295 from the Bronx. And the traveling teachers from Kansas, Miss Abbott and Mrs. Todd. And the Wilsons got here at last. The Wilsons take the motor train for an overall view of the fairgrounds. There is the symbol of the fair, the great Unisphere. Mr. and Mrs. Chandra, they're here from India. Chandra is an engineer. Here's something special, a new structural principle. He'll come back later for a closer look. Here's a pavilion with a musical spectacle. Here's a salute to the children of the world. A suspended theater with a film on the joy of living. A show where the audience revolves around the stage. Stories of the states. Places to stroll and places to rest. An old European town to wander in. Each building is an experience just to see, filled with tributes to the nations, their arts, industry, and science. the Chandras find a machine that playfully demonstrates the law of averages. Here's a new way to go to a show. The whole grandstand is lifted up into the theater. The teachers find new ways of presenting complex ideas to their students. Soap bubbles reveal the beauty of geometry. Troop 295 is doing the fair in an organized way. Miss Abbott and Mrs. Todd are going into a show on the history of communication, from tom-tom to Telstar. The Wilsons set off to explore the pavilions. Ice cream. So they lost the troop. The Wilsons enter a pavilion with a roof like a stained glass rose window. Some places make you happy just to be in them. An elevator goes up the highest tower at the fair. Troop lost again. Intensify the search, men. The teachers have lunch at the Chinese pavilion. There is a world of travel. The Chandras go to Spain. The teachers will bring back to their classes snapshots of the Far East and stories of many lands. Miss Abbott and Mrs. Todd visit Indonesia. Country after country displays its treasures. The Pietà of Michelangelo. For the Japanese, the art of drinking tea is almost a religious ritual. It's only a short walk from Asia to Africa. And here's a late arrival coming to the fair in his own way. He finds the world of the Old West. At last, the tenderfeet rejoin Troop 295 from the Bronx. The Wilson kids need a rest, and so do their parents, so they leave them in a nursery for a while. By chance, the Wilsons and the Chandras meet and join up for sightseeing. The Wilsons have never known anyone from the opposite side of the earth before. They decide to see another show together. Wilsons have picked up their children from the nursery. They go exploring a Belgian village. At dusk, a new fair comes to life.
(1939), the New York World's Fair. 1904, the St. Louis Fair. 1889, the Paris International Exposition. From earliest times, markets and fairs had been a gathering place where men came not only to trade, but to exchange ideas. As civilizations grew, as communications improved between nations, peoples of the world looked for new ways to display their industrial and cultural accomplishments. With the coming of the Industrial Revolution, the Industrial Fair was born. London, 1851. Over this world of squatting stones and twisting streets arose a strange and unbelievable structure, the Crystal Palace. It was was built for and became the symbol of the London Exposition of 1851, the first World's Fair. With each succeeding fair, people came from greater distances. Fair buildings introduced new materials in daring engineering and architectural concepts. Timekeepers of progress. In 1889, there arose over Paris the theme symbol of the Paris International Exposition, the Eiffel Tower. Designed by the greatest engineer of his time, Gustave Eiffel. Magician in iron, he was called. The great tower was bold enough to be controversial. A masterpiece of structural engineering, it remained a celebrated landmark, a symbol of world's fairs everywhere. Then, one day in March 1963, notables of both France and the United States gathered at Flushing Meadows, New York, for the beginning of construction of Unisphere, theme symbol for a new World's Fair. Robert Moses, president of the World's Fair Corporation.
We looked high and low for a challenging symbol for the New York World's Fair of 1964 and 1965. It had to be of the space age. It had to reflect the interdependence of men on the planet Earth. And it had to emphasize their achievements and aspirations. It had to be the cynosure for all visitors, dominating Flushing Meadow and built to remain as a permanent feature of the park, reminding succeeding generations of a pageant of surpassing interest and significance. What stronger, more durable, and more appropriate metal in the record of American constructive accomplishments could be thought of than stainless steel? And what builder more imaginative and competent than the United States Steel Corporation?
In most uncooperative March weather, René Legrand Eiffel, grandson of the creator of the Eiffel Tower, signaled the start of construction of Unisphere. The first member to go into place was one section of the USS Core 10 steel pedestal. Unisphere, the largest representation of our globe ever attempted. Unisphere, the largest stainless steel structure yet built. Stainless steel. Why? Because it is to become a permanent landmark, Unisphere must be virtually maintenance-free, yet remain enduringly beautiful. Stainless steel alone could do the job. Decoratively used for years by architect and designer, it was easy to suggest stainless steel's strength and beauty for a structure so large. Here's what our engineers went to work on. Assignment. For purposes of monumental beauty only, complete a feasible design for a stainless steel structure as high as a 12-story building. If Unisphere were to be harmonious when viewed from any angle, no diagonal bracing could be used between parallels and meridians. Take away such bracing, and conventional structural members normally get heavier and bulkier. But each structural member of Unisphere must appear light and attractive. Perched atop a sculptured base, which must suggest lightness and grace, Unisphere would have to withstand the enormous and changing forces of the wind, as well as its own weight. The continents and islands would act like sails, and wind pressure could exert forces nearly equal to the weight of the entire structure. Because Unisphere is open and its land areas irregular in size and position, the wind blows on either the outside or the inside, the front of a continent or its back. No past experience was available to calculate the wind forces because no one had ever built a Unisphere before, or anything like it. To meet this phase of the challenge, exhaustive wind tunnel tests were conducted at the University of Maryland. From these aerodynamic tests came the data that made design analysis possible. mathematics of analysis posed its own peculiar challenge. Unisphere had to be completed by April 1964. High-speed computers were used to solve the thousands of problems that would have taken years if attempted manually. In the design of this large bridge, for instance, it was necessary to solve only 35 simultaneous equations. In Unisphere, one problem alone required a solution of 670 simultaneous equations. Designed, analyzed, and approved, fabrication and construction could begin. Thousands of different pieces had to be cut, formed, assembled, and welded. Box girders, tubes, beams, channels, angles. Special automatic and manual welding methods were employed. An upper meridian section is welded. The South Pole is assembled. Land areas were fabricated and assembled on this turtle-shaped fitting table, which duplicated the exact curvature of Unisphere. Conformed to United States Army Engineering Corps contour maps, mountains and valleys are shown in exaggerated relief in order to achieve effective visualization of elevation. Wrapped to protect the stainless beauty, sections were shipped by rail and highway to Unisphere's site. Just ahead of the construction of the pedestal, 30 USS T-1 steel anchor bolts are set and the concrete base poured around them. First structural member to go into place is the South Pole. Next, one of Unisphere's largest members, a lower meridian, is carefully fitted into the South Pole and laid across the pedestal. Actually welded girders, the lower meridians will support the entire structure. Right at the site, many of the members are field welded into sub-assemblies nicknamed orange peel sections. To provide support and access, a temporary mast is placed along Unisphere's polar axis. When the structure is complete, Unisphere will be self-supporting and the mast removed. The southern hemisphere, like a giant bowl, is completed in 83 days. Becomes a world of stainless steel when the last flag-topped section is set in place. Now, addition of the land areas can begin. Delicate work. No job for windy days, though, because the sections act like big kites if not securely held. continents and islands in place, it remains only to